We have recently looked at residual plots, and I want to use that to take things a little bit of a step further and look at the standard deviation of the residuals to clarify any issues that we have with that. So a recent activity we did dealt with the study of the size of a house versus the price of a house in a town in California. I believe this is some 2007 data from Zillow.com. And we can see here, based on our linear model here, we have a positive association. It appears to be fairly linear. I believe the correlation is 0.78 if we look down further on this graph. So it predicts your price of the house fairly well when we have the size. One thing that we can do to feel more comfortable about this graph is to look at the residual plot and find out if the linear model seems more appropriate. When we look at a residual plot, what they do is they replace your Y values of the data with the residuals along the vertical axis. So you can focus in on how far each data point varies from our line of best fit. And half of your residuals will be underestimates, right? These points are actually over the line, and half of your residuals will be overestimates. The line is above the actual data. Okay, and what we're looking for here is a lot of noise. So it should be just very random. We shouldn't see any curved patterns, and we shouldn't see any increase or decrease in variation from left to right. Okay, and that looks like it's what's happening here. So the linear model appears to be fairly good in this particular instance. Okay, one other thing that we haven't really talked about yet, other than the Desmos activity recently, was the standard deviation. So when you do the summary statistics for this, you get a standard deviation. And what does that mean? We'll also, in a video upcoming, we'll look at what this R squared means, but we'll focus on S for now. So in our activity on residuals, we saw this formula. So this is the standard deviation for your residuals. It's very similar to standard deviation in Unit 1 for just one variable data, but you'll notice some differences here. So a lot of things are very similar. So we've got deviations or your residual here from the predicted Y. So your individual value of Y minus the predicted value of Y, so your residual. We know that the sum of those would just be 0 if we added them as is. So what we do is we square them and then add them together. Now, in regular standard deviation, we divided by n minus 1. It happens to work better that dividing by n minus 2 works more predictively for us when we're talking about residuals. So that's just a slight variation in the formula. And then that will be your variance in your residuals. And the final step would be to take the square root. So very similar to what we learned in Unit 1 with just one variable data, but just some slight differences here. So what this tells us is how much the typical residual varies from your line of best fit. So that's a little bit different than Chapter 1. Remember, the standard deviation for just one variable data told us how much a typical value varied from the mean. This is telling us how much we vary typically from the prediction line or the line of best fit. Okay, so when you see that listed, you want to be careful when you're describing that. So usually you'll be showing that in a printout. So look for that number, and knowing what it means is important. So about every residual varies, or not every, the typical residual varies from the prediction line by about $51,000. Okay, and in normal senses that seems like a lot, but when you're talking about housing prices, that's not that much of a big deal. So the typical variation, how much does our residual vary from your line of best fit? It's about $50,000 in this particular case. Okay, so that's how to interpret that statement. And hopefully now we're comfortable with what a definition of a residual is. It's basically like your deviation from Chapter 1, except for instead of a mean, you're deviating from the regression line. Your residual plot tells us how well we predict using a linear model, and this S tells us how much our residuals vary from the line of prediction. Okay, very good.